Hello and welcome to a tutorial in CS 4010, the structural dynamics and finite element analysis. In this tutorial, I'm going to guide you how to draw a bridge with the new tool, the Ansys discovery geometry. So first of all, we need to create a project for that. So please click on static structural, double click or drag it over. Now, I don't want to change anything in engineering data. I can change it later. I just go straight to the geometry. If you right click to that, you can choose a space claim or design modeler. But if you double click on this, by default, it will choose Ansys Discovery as a tool to open the geometry. So here is the interface of geometry. You can see that it's very similar to the Ansys space claim before, but there are some small differences that can make you a small hiccup when you try to design it. So first of all, I will try to select the plane I'm going to draw it. So I click on new plane and I choose the ZX plane to draw my bridge. The main reason is because I'm going to have the gravity goes against the z-axis. Now I can select the right face for me. You can use this as a rotation cube, or you can select the face for you to draw. Yep. So now the first of all, I need to create a new component. So right click here and start a new component. This will be my component for the I200, for example, like that. So this will be the cross-section area about 200 something. Now I need to draw my line first, so I click on line and click on the origins and then go along the axis to get it about 10 meter. Yep, and that is enough for me. Now I try to use array linear pattern to create 10 of them, that 10 spans of the bridge, and each of them could be about 10 meters apart. And I select the directions. So it's going to create about 10 lines going this way. If I don't like the direction, I click on it again to go to the opposite side. But for me, I think I want to go along the axis. So I choose this side, and I think that's fine for me. So click on confirm to create it. Now you can see that in your component, you will have curves and about 10 lines of this, like that. In the next step, I need to create a new component. I think I need to close the linear pattern first. Now I can right click on design and create a new component. And I call this one to be arc. Now, in this one, I'm trying to draw a 3-point arc. Yeah. So from this end. Now, please remember that when you have the snap is square, that means it's closed. You must wait until the time when your cursor turns to a circle, something like that. So I may go from this side, maybe easier for me. You can see that this is a snap to the end of element. And then I can go to other side. All right, 100 meter. And then I can get the opening about 13 degree, something like that. So this is my new arc. I just draw. Now I want to double check it, so I zoom in. You can see that they are not exactly the same as I told you before. So I can move it back here to have exactly at the origins. Yeah, I think all good to me. Now I need to create a new component for the vertical beams. So I call it maybe I250, something like that. I to 50. Yep. Now I can start drawing it vertically up. So try to draw it vertically up this way. Line again. Now you can see that I couldn't find this one because I'm in another component now. So a good way to do that is you turn on the 3D sketching. Alright. And I often have the view isometric. So it helps me a lot in drawing. Now I can use this line. Now I can snap to any end. And ensure that when you go up, it has the rectangle, the square angle. Otherwise, it may go to somewhere else out of your plane. And again, one more, going up. Please ensure that your cursor turn to a circle, not a square. Yeah. So they are the vertical lines for me. To strengthen the bridge, I can make some cross beam. So I can go from maybe from here to the end over here. Yep, I think it's fine to me. Now, in the next step, I'm going to copy all of this to make the other side of my bridge. So I select all of them, click on the first one, and then hold the Shift key, and then open the next one. If there's only one, I hold the Control key. And then for the next one, open this, I hold the Control key. And to hold several of them, I hold the Shift key. I haven't selected this one yet, so I hold Control and this one. Yep. So now I select all of the beams and I just copy to the other side. So I use the linear pattern again. And I go by the y-axis and I have only 2 copies only. Now the width of my bridge can be 10 meters as well. So it's going to be 4-lane bridge. I think 4-lane is fine for me. And then I click on the direction I want to go. So you have to wait a second. It's going to create a copy on the other side of the bridge and you can confirm it. Yep. Now I need to draw the connection between 2 sides. So I can create a new one. Create a new component. And I call it, for example, I22, something like that. And then I can start drawing the connections. Yep. So please zoom in or out to avoid the obstacle. Now I can make another line for cross line. Yep. And I make a copy of them. So this one, I take the linear pattern and go by 11 by 10. Yep. And I confirm it. For this one, for example, I can create linear pattern and I go by 10 and I click on the directions and I confirm the creation. Right, so that's a quick way how I can make the bottom, the support for the deck of the bridge. Now the top also needs a connection. Please do not create the connection for the first pane, because if you click the first pane, you will be too low. So here, my height of the first pane is just only 2.4 meter. If you make a cross beam over here, so it's going to block all of the high chuck that it can come over to your bridge. So just start from the second span. So this can be my first one, second one, yeah, and I think it's fine to me. Please remember two principles: that you must snap from end to end, and you shouldn't cross another element. Otherwise, they may not share the topology when they deform. The problem for enabling the 3D sketch is that you may snap to a point on another plane. So therefore, please very frequently check your bridge. Alright, to assign the beam cross-section to the lines that I just draw, I need to select the line I want to assign first. And then I go to prepare and then go to assign. You can see here the list of the cross-section you can assign, but there are quite a lot. So therefore I use a filter to filter the one I need. So I can just untick the one I don't like. I like the rectangle because the rectangular one is always better for my calculations. And then I use, now it is a I200, so I can scroll down very quickly to find the smooth one for me. So 200 by 10. I don't know which one is good. Let's try a big one first. Yep. Done. Now you can see that a new property table will appear. You can see the dimensions. You can change the section depth, width, and thickness if you want to. I think I'm fine with all of this, so I just click. Now, when you zoom in, you don't see the beam yet. They just become a thicker line. So to see that, you click on display and you display the 3D profile. It will take a bit, but you can see that when you zoom in, you can see that this is a rectangle, and you can change your orientation if you want to. For me, the vertical profile is absolutely fine. Yep, and now I keep going for other beams. Now for the arc, I may choose something a bit bigger. And I may choose a circular one. I think I can choose 500 can be way too much. So how about 300, something like that. Yep. So you can change it and please ensure that you change it accordingly. So the depth and the width must be equal. I think I'm fine with that. And if I'm zoom in, I can see that this is a circular cross-section area. That's okay for me. Now, I keep doing for the other one. Just choose a random one. I don't really design a very accurate one now. So I just try to make all of them done. So select all of the line. This is E202. So I try to get rectangle one again and get 202 something. Yep. 220. I think I'm fine with this. And then assign the last one. So a good tip for you that when you see here, you can see the beam. But when you see here, you can see the curve. So that's the lines you haven't assigned the cross-section area yet. So click on assign again. And let's see this one, 250. So I just choose 250. Yep. So now you can see that all of my lines become the beams. So that's good. In the next step, I think I need to create a deck. So I just use a design and maybe I need a new component. So I create a new component and I call this one the deck. And I try to draw a rectangle. Because the deck is a flat plane, so therefore I need to back to the plane. I have to choose my plane first. I untick this and try to choose the plane I want and then click on this. In space claim, you need to draw a small square, but I think in discovery it's okay to make a big plane like this. Yep, and I think that is fine. When you click on any other command, it's going to convert your rectangle into a plane like that. This is an area. Now, before we can use this for our model, we need to make it a shared topology. So please click on prepare, and then you can pre-check if there is any problem, or you can click on share. Yep. So you can see that they will highlight the share boundary or geometry you are going to use. And you also can have the ability to change the properties. For example, you want to make the tolerance is larger. 0.002 meter is way too small. So for example, I can make it larger and I can confirm. Yep, I think this is good now. I save it and then I can use it for my model. So just close it. And you open your model by double click on it. Alright, so I have it here. So this is my deck. And here is my bridge. I think I'm fine with this. Now you can Notice that there are some different marks over here. If it has a green tick over here, that means it's okay. If it has a question mark like here, that means it needs some more information. So just click on that, open it. You can see that all of the information about the beam has been assigned, but there is no information about the deck. So please click on here and assign the thickness, for example, 0.2 meter. And for the material, please choose concrete. And if you don't have it in your library, you can import it from the general library. And that is now on green tick. You can go to mesh to see how it works and generate a mesh. So this mesh may be too coarse for me. I want a smaller one, so I can change the size. For example, I add to maybe 1 meter, better. Yep, and then I update the mesh. So now the mesh is a bit coarser to me. I still want it to be smaller, so I change it to 0.5 and I update it. Yep, so it's really small now. I think I'm fine with this meshing. And if you want to see the statistics over your model, you can just click on the statistics, and then you can see number of nodes and number of elements you have used. The more number of nodes and elements, the slower the computation will be. Now in the next step, I need to go to the model and I add a fixed support. The bridge I have may have several fixed support, but for the simplification, I just assume that it has only 2 fixed support at 2 ends. So first of all, I choose the selection, so I choose the edge only. And then I click on the first edge, and then the second edge. Just hold Control so you can select 2 of them together. Yep, and after that, I can click on Fixed Support. Yep, so now you can see that I have a new fixed support. But I still cannot do solution yet because I don't have any load. For example, I just try to do the inertial gravity. So by the standard, it's going down and against the z-axis. So I think I'm fine with that. Now I need to tell the Ansys that which information I want to see. So first of all, I need the total deformations, the principal strain, the maximum principal, the maximum shear strength, maybe the equivalent. I need also the maximum stress and the minimum stress. No, the maximum shear and maybe equivalent stress. I also can insert a beam tool over here, so you can add the beam design, or you can just right click here and insert and then get the beam design about the actual force. You want to see that, or you can get the beam tool. Alright, in the beam tool, you can see the direct stress, the minimum combined, and the maximum combined stress. So just solve it. Right click and solve. Alright, all done. Now here is the total deformations. Don't be scared because it is exaggerated. You can see the scale over here that it has been amplified by nearly 4 times. So you can choose the true scale. So it's still bent, but less scary. Now, the bad thing for my situation is, I think I have very huge deformations. The maximum is about 1.2 meter. That's quite a lot. To reduce it, I need to increase the size of the beam maybe over here because I have the maximum deformation right here. So I can go back to my discovery and change the beam cross-section area. Now, in the next situation, I want to see the maximum precessional stress. The stress will be on the deck only because the beam is a 1D element. So therefore, it doesn't have stress in that, it has the actual force. So the stress, we can see here the distribution. I think I'm fine with that, but the stress is really huge at the connections, maybe because of the high moment, or maybe the gravity. And here is the actual force inside the beam. Yep, so you can see that the arc actually has a very low stress and is in compressions, while these beams are in tensions. Actually, it's not so. So it's really high compression actually, because it's in 10 power 6, so in megapascal. Yep, if you want to see the exact number, you can use a probe. So click on that, and you want to see the probe of the point where you are interested in. So you can see that. Click on that, you will give the node number and the information about that. You also can use the maximum and the minimum to find the most in tension and the most in compressions. You also can use beam tool to find information about the direct stress and the maximum combined stress in the beam. So please design your bridge wisely and according to the standard. I hope this tutorial helped you to have an idea how to use the Ansys discovery for your project. Thank you very much and see you in the next tutorial.